Lightning. There are few natural phenomena that inspire as much wonder as a thunderbolt streaking across the night sky only to come to ground in a powerful flash of brilliant light. Lightning scientists, like myself, examine lightning from the ground and from space to try and gain a better understanding of the physics involved in these energetic discharges, how the flow of current through them affects the Earth's system, and ultimately how lightning production is tied to the meteorology of the parent thunderstorm. One such lightning sensor can be found on the new GOES-R weather satellite. From its perch at 35,000 kilometers above the Earth, the Geostationary Lightning Mapper, or GLM, records all types of lightning flashes across the entire Western Hemisphere, 24 hours a day, 7 days a week, and at 500 frames per second. The temporal resolution of GLM is high enough that we can actually trace the horizontal paths that lightning flashes take as they progress through the clouds. This allows us to identify expansive flashes that span dozens to hundreds of kilometers end to end, for example this case to my right, and also some complex cases of spider lightning that form into many branches as they evolve. Having a lightning sensor like GLM in geostationary orbit allows us to watch storm systems grow and develop over their entire life history. For example, there is the case of Hurricane Harvey. Let's take a closer look at the hurricane by moving down to a low Earth orbit. Now from this vantage point, which is at a comparable altitude to the International Space Station, we can see the clouds being illuminated by lightning flashes much more clearly. Yellow lines can also be noted that trace the paths of individual flashes as they progress through the clouds. The lightning in Hurricane Harvey is fascinating because flash rates in the outer bands increased as the storm intensified, and lightning could even be noted in the eye wall. This is important because increasing lightning activity in the eye wall often signifies changing hurricane dynamics. In the case of Harvey, this meant an intensification to a Category 4 storm before becoming the first hurricane since 2005 to make landfall in the United States. It came ashore in the Houston area at 10 p.m. local central time on August 26, 2017, as the strongest hurricane to impact Texas since 1961 and causing an estimated $125 billion in damages, primarily due to flooding. From our low Earth orbit view, we're still a few hundred kilometers above the storm. We can immerse ourselves in electrified clouds and use radio waves to map the three-dimensional structures of lightning discharges. Let's go now to where the lightning is. Now we are at an altitude of just 10 kilometers, in the heart of a northern Alabama thunderstorm. This altitude equates to about 32,000 feet, so imagine that we're in a commercial jet as it descends into the Atlanta International Airport. You don't see any clouds because radio lightning sensors see through them, like X-ray vision, leaving just the lightning channels behind us in the night sky. These channels contain large amounts of current, up to 50 kiloamps. That's enough energy to power 100,000 smartphones for a fraction of a second. But there is no cause for concern in our simulated aircraft, since modern commercial jets are equipped with exceptional lightning protection. In fact, the most recent commercial plane crash directly attributed to lightning occurred way back in 1967. Unfortunately, lightning can still be deadly back on the ground. Each year in the US, about 400 people or more are struck by lightning, resulting in an average 60 deaths. On stormy days, like this day here in College Park, Maryland, you should go indoors at the first sign of lightning. If you can hear thunder, then you're already close enough to the storm to be impacted. So save the urge to stand outside on an exposed rooftop for our virtual reality, because any of these cloud-to-ground flashes you see behind me could strike you. If you happen to be caught off guards in a sudden storm, avoid open areas. Stay away from tall trees, towers, or utility poles. Lightning is more likely to strike these taller objects, but can also travel long distances through conductive materials, like metal fences, for example, so always be aware of your surroundings. Remember that lightning is a spectacular force of nature. There's a reason, after all, why people like me study it, but it is one that should always be treated with the utmost respect.